one of the most important aspects of science is experimentation. And experimentation means that, generally speaking, we're making observations that involve recording numbers or measuring values of some variety. There are, however, some basic rules that we need to follow when making these measurements. All numbers that we take directly from a measurement within an experiment are what we define as being quote-unquote significant figures. However, there are some values that are not significant, and that occurs when we convert from one unit to another. Those things we refer to as placeholders. To understand which figures are significant and which ones are not, we require a little understanding of how measurements are made in the first place. So what we're going to do is we're going to take a look at a couple of rulers of varying degrees of precision / quality. Our first ruler, as you can see, is in centimeters, but if you notice, this particular ruler doesn't have any fine markings within it at all. Compared to the ruler below, which you can see we have the finer gradations, which we refer to as the millimeter markings. Both instruments will measure the length of this line that is visible here on the screen. However, one of them will produce a higher quality result than the other. Now, when we make a measurement in physics, we specifically have to ensure that we do the best that we possibly can. Now, if we take a look at this first ruler here, I think we can all agree that this line is at least 5 centimeters long, but not quite 6 centimeters. However, if we were to just write 5 centimeters as our value, clearly that is a poor approximation of what that value is. 6 centimeters is equally as bad. Therefore, what we must include in this measurement is a guess. Well, how do we make the guess? Well, we need to make a guess within the gap provided between 5 and 6. And the rule is we can only guess to 1/10 of that gap. In other words, we can only guess this length to be either 5.1, 5.2, 5.3, etc., up to 5.9. So you do the best of your ability, but if you look carefully, it is very hard to see where that is. To my eye, that appears to be slightly past the halfway mark. So the best guess you can come up with based on your limited ability to observe is 5.6 centimeters. Now, this 6 here, that is our guess. And based on this instrument, we are not entirely confident that this value 6 is exactly 6. It is a guess. And there will be clearly some error inside this guess. But that's the best that we can do. Now, when we take a look at this value, 5.6 centimeters, what we have here are we have two figures generated in this. We have a 5, which we are 100% confident with, and we have the 6, which we are not so sure about. But those are the only two numbers generated from this. If you count the number of figures that we have, there are 2 of them. Therefore, there are 2 significant figures in this measurement. The 5 and the 6 are part of the measurement, and we consider those to be significant. Now let's compare that to the tool below here. Now if we look at this tool below, now we can see that we have a little bit more precision in our instrument. Now to zoom in here, if we look at this little section, we can see that our line actually didn't quite make it all the way to 6 on the 0.6 mark. It falls somewhere between this 5 mark and the 6. Since we have a better quality instrument for this measurement, we can get a better guess out of this. And in this case, if we take a look, we are 100% sure about this 5. Now if we look down here, we're also 100% sure of the next 5. So we got a 5.5. Now what we need to do is we need to take a guess inside here. How much would this value be? Well, looking at it, it looks to be about halfway through. So your best guess would be around 5.55. Some of you may think that it's a little further. You could call it 5.56. Some of you might see it as a bit smaller, maybe 5.54. all of these are actually reasonable guesses. In my opinion, the 5.55 is our best guess. Now, this particular measurement, as you can see, it has 3 significant figures. All right? We have 3 5s generated in this measurement. When we used this piece of equipment, we only got 5.6, only 2 significant figures. So as you can see, this lower quality instrument produced only 2 significant figures, where the higher quality instrument produced 3 significant figures. Before we go on to more examples, let's summarize this rule. So the rule, when making your guess, you can only guess as deep as 1/10 of the smallest scale. So that means, in this particular case, that 1/10 of the smallest scale means 1/10 of this gap right in here. So only 1/10 of that gap. So depending on what type of instrument, if the smallest units on your instrument are the centimeters, your guess has to be to the 1/10 of a centimeter or a millimeter. If the smallest markings of the ruler is the millimeter, then your guess must be 1/10 of a millimeter. And that's how we got the difference between 5.6 centimeters on the first tool, that was 1/10 of a centimeter or a millimeter, versus 5.55 centimeters. And this is equal to 1/10 of a millimeter. This right here is the millimeter. This right here is the 1/10 of a millimeter. All right, let's take a look at another example. So when you look here, in this instrument, we are 100% certain that the first digit is going to be a 3. Then what we have to do is we have to break this up into tenths and see which one this is closest to. This, to my approximation, looks like it's closest to 8. So 3.8 centimeters. And now we have 2 sig figs out of this measurement. Okay, so what happens in the next measurement? All right, well, in the next measurement, down below, let's see what we got going on here. Let's bring this up a little closer, and let's zoom in. With this here, it looks like it falls exactly on one of these finer gradation marks. Well, what do we do in that particular case? Well, it looks like in this particular case that, again, we are very confident with a 3. And that looks to be 6, 7, 8. But we still have to include our guess. We have to guess to the 1/10 of this smallest gap here. Well, it doesn't appear to be anywhere past 8. It looks like it's exactly on 8, which means we have to add a 0 at the end. This 0, that is our guess. And that says that we believe that it lines up exactly on one of those lines. So with this value here, we have, out of this instrument, 3 sig figs. That 3 is significant, that 8 is significant, and the 0 is our guess, but it is significant. All right, it's part of the measurement, and it must be included. So let's recap and look at this measurement here. With our first lower quality ruler, we were 100% confident with a 3. And we guessed that this was an 8. And we were unsure of that. This gives us 2 significant figures. With this measurement over here, we have a better quality instrument. So we are 100% sure of that 3. And we are now 100% sure of that 8. Both of these we are very confident with. But we have to make a guess, and our guess at the end is the 0, and that is our best guess. This measurement has 3 significant figures. Okay, let's take a look at one more example. So again, let's take a look at this line here. Well, this 8 appears to line up exactly at that point. The line appears to line up exactly on our value of 8, but of course, every time we make a measurement, we still must include a guess. So for this instrument, the first number is 8, and we are guessing that that is a 0. And again, this 0 represents the 1/10 inside this gap. All right? So we have got 8.0 centimeters. In this tool down here, when we take a look at this value here, we have to guess to 1/10 of the smallest gap. So we have to use every part of the tool. So that means for this one, 8 represents this number. This represents millimeters, which are the smallest markings on our instrument. And in addition, there is our guess. In this first example, this instrument only produced 2 significant figures, where this instrument consistently produced 3 significant figures. So now here are the general rules for significant figures. Now we know what the difference between a sig fig is and what isn't a significant figure. So any number that's generated in a measurement is considered significant. But here are the basic rules. Rule number 1, all non-zero numbers are considered to be significant. So in our first example, our 4 and our 5 are non-zero. Now these 3 zeros are here, we call these placeholders, and they are not significant. So in this case, we only have 2 significant figures. Same with this example here. 2 non-zero, these are considered the only values that are significant, and that 0 there is a placeholder. So again, 2 sig figs. And in our final example here, the 7 and 8 are significant, and those zeros are placeholders. So again, 2 sig figs. So again, all non-zero numbers are considered significant. But sometimes zeros are considered significant. And those are the cases where the 0 is sandwiched in between non-zeros. So let's take a look at this value here, 8,091. This 0 here is sandwiched between the 8 and the 9. Therefore, when we've got this sandwich effect, everything that's non-zero, including the sandwich, is considered significant. So this would be 4 sig figs. In this example here, the 6, the 7, the 9 are non-zero, and this 0 here, it is sandwiched in. So therefore, this also has 4 sig figs. And in our last example, the 7 is a non-zero, the 8 is a non-zero, the 1 is a non-zero. And we have 2 zeros, these ones right here, that are sandwiched in between. That makes them part of the quote-unquote 0 sandwich, as we have written up here. And that means that they are as well significant. So this one would be 1, 2, 3, 4, 5 sig figs. Next rule. What if we have trailing zeros? Well, this is similar to the measurements that we made up here in this example here. Now, if you recall, in this example, we got a measure of 8.0. That 0 is what I mean by a trailing 0. Take a look at this example up here. This was 8.00. These 2 here are what I consider to be the trailing zeros. Those are part of our measurement. So when you see something written like this, with this trailing 0 here after the decimal spot, that gives you a clue that that is significant. And the reason why it's significant is as follows. You don't normally have to put a 0 there to represent 91. You just need this for a 91. So if you add a 0 to the end, that's kind of a weird thing to do, unless it's significant. Hence, this is the reason why I call it the weird rule. It's weird for that 0 to be there unless it's part of the measurement. And that's how we know that it is significant. So we don't normally have that 0 there. Since it's there, that means it's significant. So here we have 3 sig figs. Let's take a look at this measurement here. Here's a trailing 0 over here. That is also kind of weird unless it must be part of the measurement. Therefore, all of these values must be significant. So in this case, we have 4 sig figs, right? 3 non-zero and 1 trailing 0. And this final example, we have 3 trailing zeros. Again, kind of a weird thing to do unless they were part of the original measurement. So they must be significant. These are non-zeros over here, so they're significant. So all of these are significant. So now we have 6 sig figs. Final rule for what makes things significant or not is occasionally when we're making a measurement, we sometimes have to convert from one unit to another. So let's say, for example, we measure something in meters and we need to convert it to something like millimeters. When we convert it to millimeters, we will generate a couple of extra zeros here. But let's say this zero here was part of the measurement, but when we made the conversion, we added a bunch of placeholders. In order to distinguish between which zero is significant as part of the measurement and which one is insignificant, we add a tilde to the top. So without this tilde, this only looks like 2 sig figs. However, with the tilde, that means that 0 is significant. That makes it 3 sig figs. In this example here, that tilde makes that significant. We have the 0 sandwich and the non-zeros, so we have a grand total of 4 sig figs. These 2 zeros are placeholders. And in the final example, non-zero, this is significant, 0 sandwich. All of these are significant, 1, 2, 3, 4, 5, and this is 5 sig figs.